Hello and welcome to this video on how to run path analysis and test mediated effects in the Mplus software. My name is Geiser. I'm an instructor and statistical consultant with QuantFish, and on this channel I present weekly statistics tutorials. I usually talk about multivariate statistical methods including structural equation modeling, factor analysis, latent class analysis, and multi-level analysis. If this is something that interests you, then please subscribe to this channel. Also, don't forget to hit the like button and to check out the description for additional resources, including courses that I teach for QuantFish. In this video, I want to introduce you to path analysis in the Mplus software and to how you can test mediated effects or indirect effects in the Mplus software. Why would it be useful to consider using Mplus for path analysis? One advantage of Mplus is that it allows you to analyze path analysis in a single step. So you don't have to specify and run different regression equations or regression models to get your different effects, but you can specify a path model in just one step, in one input, and Mplus will allow you to print the direct, indirect, and total effects, and also to test them for significance using appropriate methods for testing those effects. And so I want to show you how this works here based on a simple example. It's a simple 3-variable mediation model with x, m, and y, and it is based on a substantive example that was presented by Whitelaw and Liang in the area of health psychology. In this model, X is physical health, so this is a variable that reflects a person's objective health status, for example, a health score that is obtained from a doctor or a rating based on parameters that are assessed in a medical examination. And then M, the mediator, is functional health. Functional health is something like, for example, the ability to climb stairs or the ability to walk or to do simple tasks in daily life. And so this is something that would depend on physical health. Obviously, if you're not in good health, then there are certain things that you cannot do, such as, for example, climb stairs or run a marathon or something like that. And then finally, the dependent variable in the example here is Y, subjective health. Subjective health is a person's self-rated health status, and that depends in this model on both their objective physical health status and also on their functional health. So individuals who have higher functional health tend to report their subjective health as better compared to individuals with lower functional health, and the same is true for higher functional health having a positive association with subjective health as well. And so the question in this model, or one question, would be whether there is an indirect effect of physical health on subjective health via functional health, so a mediated effect from X via M to Y. And so this can be tested in a path analysis where we estimate those 3 paths simultaneously. The X to M path is known oftentimes as the A path, the M to Y path oftentimes is labeled as the B path, and then the direct effect from X to Y is often referred to as the C path or C prime path. In this example here, I want to show you how you can set up this model in Mplus and also how you can test the indirect effect using so-called bias-corrected bootstrap resampling, and more specifically by looking at confidence intervals that are based on that bias-corrected bootstrap method. Why can we not just simply test indirect effects using conventional standard errors and conventional test statistics? Why do we have to use fancy bootstrapping? The reason is that the indirect effect is the product of 2 path coefficients. In this case, it would be the A times the B path, so the path from X to M times the path from M to Y that constitutes the indirect effect. And so an indirect effect is the product of two or more path coefficients, and it's by definition not normally distributed. And so therefore, because there's not a normal distribution of this product, the best method currently available to test indirect effects are bias-corrected bootstrap confidence intervals that are asymmetric and that allow us to test these effects appropriately. And so I want to show you how this works in Mplus. The first thing that we're doing here in Mplus is we are defining which data file we are using in our analysis. So this data set is called health_manifest.dat. So that's our data file, and this data set contains three variables: pH, FH, and SH. So physical health, functional health, and subjective health. Those are the three variables in this order in the data set. And next, in the analysis command, we specify the number of bootstrap samples. In this case, I requested 1000 bootstrap samples for the analysis. And then in the model statement, we specify the three paths. So you can see here, SH is subjective health regressed on FH. So this would be the B path, so the path from the mediator functional health to subjective health, our outcome variable Y. So here we have the B path, and then SH is also regressed on physical health, which is the C or C prime path, the direct effect of X on Y, or physical health on subjective health. And then the next on statement refers to the regression of the mediator FH on the exogenous variable physical health. So that would be our A path that is specified here with the second on statement. The on statement in Mplus is generally used whenever you have a regression of dependent variable on one or more independent variables. The dependent variable appears on the left-hand side of the on statement. The independent variables appear on the right-hand side. So this can be read as saying subjective health is regressed on functional health and physical health, and functional health is regressed on physical health. Furthermore, when you have a mediation model where there's an indirect effect, where you have a mediator variable or more than one mediator variable, Mplus allows you to define the indirect effects and print them using the model indirect subcommand in the model statement. So model indirect here allows us to define which indirect effects we would like to look at, because in a more complex model there could be multiple indirect effects and maybe we don't care to look at all of them, and so then we can just simply pick specific ones. In this case, there's only one indirect effect, and that's the indirect effect to subjective health from physical health via functional health. And so we get that indirect effect by specifying SH IND for indirect pH. And so then Mplus will print all indirect effects from physical health to subjective health, in this case only one, the one via functional health. And it will give us a test of significance as well for this indirect effect. Now, normally when you don't include the bootstrap procedure, Mplus will simply use the so-called Sobel method or Sobel test for calculating a standard error and a z-statistic, a test statistic for the indirect effect. And that's considered suboptimal by some statisticians. What is more recommended for testing indirect effect is the bootstrap, because that allows you to construct asymmetric confidence limits so that you can take into account the non-normal distribution of the product of coefficients. And so that's what we're doing here by specifying bootstrap is 1000, meaning that's the number of bootstrap samples, and then also by including the output command C interval BC bootstrap. So this allows us to print confidence intervals. If we didn't include the BC bootstrap subcommand here at the end, then Mplus would just simply give us only the confidence intervals. So if we included only the C interval keyword without the BC bootstrap in parentheses, then we would get conventional confidence intervals that would be based on conventional bootstrap in this case, or if you didn't have the bootstrap sample command here, then the C intervals would be based on asymptotic standard errors, meaning ones that are theoretical standard errors and not bootstrap standard errors. But so here, since we're including the bootstrap option and the BC bootstrap specifically, we will get asymmetric confidence limits for all effects, including the indirect effect in Mplus, based on bias corrected bootstrap. Now let's scroll down and take a look at the output file. You can see the input reading terminated normally. We had a large sample size here, 1648. And the first thing that we should do is we should take a look at our sample statistics. Here you can see the correlations, and so in the correlations you can see functional health is positively correlated with subjective health, so higher functional health is associated with higher subjective health. That makes sense. You can also see that functional health is negatively correlated with physical health, and so you might wonder why that is the case. The reason for that is that physical health here was measured as the number of sicknesses that somebody had in a given year, and so it was, so say, negatively coded. So higher scores on physical health actually meant more sickness, less health, and so therefore it also makes sense that the physical health variable here is negatively correlated with functional health. Functional health was positively coded such that higher scores indicated greater functional health. Now this also explains why physical health is negatively correlated here with subjective health, because again, physical health is the number of sicknesses, and so the more sicknesses somebody had, the lower their self-rated health, subjective health, and so therefore this is also or it makes sense that this correlation here is also negative. Furthermore, down below we get model fit statistics, which in this case are not meaningful because we have a saturated model here, which you can see from the fact that the test of model fit has 0 degrees of freedom, and that's because a model with just 3 variables and all 3 paths estimated is a saturated model, a just identified model that does not place any restrictions on the data. So this model test therefore is not meaningful. It's 0 because the model cannot not fit. It must fit because it is a saturated model. Below we get the model results, so specifically the A, B, and C or C prime paths. You can see first of all we have subjective health regressed on functional health, so that's our B path here. This is the unstandardized estimate, 0.885. You can see the standard error here, and then a Z statistic, which is given as the estimate divided by its standard error. You can see this is a large Z statistic, and that results in a p-value that is very, very small, meaning the point estimate of the B path here is statistically significantly different from 0. We also find that the path from physical health to subjective health, which is our C path or C prime path, also is statistically significant at the 0.05 level or even 0.01 level. So this path is also different from 0. And then finally we get the A path, which is from physical health to functional health, and that path also is statistically significant. If you cared for standardized coefficients, standardized path coefficients, then you find those under standardized model results in Mplus, and STDYX is the completely standardized solution where all variables are standardized to a variance of 1. And so the standardized coefficients can be found here, where the B path is 0.486, the C or C prime path is negative 0.24, and the A path is negative 0.447. All of them are statistically significant. You also get the intercepts of the regressions and the residual variances or error variances, as well as the R squared at the end. You can see that for functional health, we were able to explain 20% of the variance, so the mediator here is explained by the exogenous variable physical health. So physical health explains about 20% of the variability in functional health, and then about 40% of the variance in subjective health can be explained by physical and functional health combined. Below is a summary of the total indirect, specific indirect, and direct effects in Mplus. You can see the total effect here is negative 0.178, and again that would be the unstandardized metric here first. The total effect is the sum of the direct effect C plus the indirect effect A times B in this case. And the total indirect effect here, which is also equal to the single indirect effect that is only present in the model, is negative 0.085. That's the product of the A and B coefficients. So the indirect effect, which is given here again as specific indirect, that's the product of the A and B paths. And so we can take a look at its p-value, which here is then based on bootstrapping. However, this is not the best test. A better test is to look at the asymmetric confidence intervals, which I will show you below in a little bit. We also get the direct effect again, so that's the C path or C prime path, which we have already seen. And then all this is also reported in standardized metric below, so you can take a look at the total and indirect effect also here in standardized metric. And then after that are the confidence intervals, which are based on the bias corrected bootstrap. And so you can see here that first of all Mplus outputs the confidence limits for the A, B, and C paths. Under estimate you can see those reproduced. Again, those are first of all unstandardized. So here we have again our B path, and then we have our C or C prime path, and then finally we have the A path here. These we have already seen. And then to the left and to the right you can see the lower and upper limits respectively of those of different confidence intervals. First is a 10% confidence interval, which you can find under lower 5% and upper 5%. And then next is a 95% confidence interval, for which you can find the limits under lower 2.5% and upper 2.5%. And finally, Mplus also gives you the lower and upper limits of a 99% confidence interval, which you can find here under lower 0.5% and upper 0.5%. Now, these are potentially of interest for these direct effects A, B, and C. However, they are mostly interesting for us for the indirect effect. And so that can be found further down below the standardized confidence intervals. And so when you go to confidence intervals of total indirect, specific indirect, and direct effects, that's where you would be looking, that's where we would pay most attention to, is here these confidence intervals for our indirect effect, which are given here. And so you can see that again the point estimate of the indirect effect A times B is negative 0.085 in unstandardized metric, and a 10% confidence interval ranges from negative 0.096 to negative 0.074. So that confidence interval here does not include 0, which means the indirect effect is significant at an alpha or significance level of 10%. So if you're testing at a 10% limit, then or 10% alpha level, then the effect would be significant. However, that's not so common. Usually we test at a 5% level or at a 1% level. And so then we would be looking at the 95 or 99% confidence interval. Let's do that as well. So for the 95% confidence interval, we would look at lower 2.5% and upper 2.5%. And so that ranges from negative 0.098 to negative 0.072. And again, that does not include 0. So in this interval, 0 doesn't fall into it. Both of the limits are negative. below 0. And so, therefore, the effect is also statistically significant at the 5% alpha level, because a 95% confidence interval does not include 0 in this case. So the effect, the indirect effect, is statistically significant also at the 5% level, alpha 0.05. And we can check as well whether the effect would be significant at the 1% level. We would do that by looking at lower 0.5% and upper 0.5%, and we can see that that ranges between 0.101 and between negative 0.101 and negative 0.066. So again, that also does not include 0, this interval, for 99% confidence, and so the effect then would also be significant at the 1% significance level, or alpha equals 0.01. So that's what you can conclude from these confidence intervals, which are based on the bias corrected bootstrap, and you get those also for the direct effect, and you get those also for the total effect up here, so you can look at those as well. And you also get them for standardized effects. So when you look at the STDYX standardization section, you get the same information here printed also for the standardized total, indirect, and direct effects. So that way you can test your indirect effects properly in Mplus along with the A, B, and C paths. I hope you found this video useful to learn about how to specify path analysis in Mplus and how to test indirect or mediated effects in Mplus using bias corrected bootstrapping. If you like the video, please subscribe to this channel, hit the like button, and don't forget to check out the description for additional resources, including courses with Mplus that I teach for QuantFish.